The entity relationship model was introduced and formalized by Chen in 1976. It is one of the most popular data models for conceptual data modeling. It has three building blocks: entity types, attribute types, and relationship types. Entity types are similar to record types in the hierarchical or CODASYL model. The R model supports simple attribute types, composite attribute types, single-valued attribute types, and multivalued attribute types. Relationship types can have any degree, such as unary, binary, ternary, etc. All cardinality ratios are supported, such as 1 to 1, 1 to n, n to 1, and m to n. Relationship types can also have attribute types. The R model has an attractive and user-friendly graphical notation. Hence, it has the ideal properties to build a conceptual scheme or model. An entity represents a business concept with an unambiguous meaning to a particular set of users. An example could be a particular student, product, supplier, or employee. An attribute represents a property of an entity. A particular entity will have a value for each of its attributes. Think about a student's name, a product's color, or a supplier's address. An entity type defines a collection of entities that have the same attributes and represent similar business concepts. In other words, entities are said to be instances of that particular entity type. An attribute type defines a collection of similar attribute values. An attribute value is an instance of an attribute type. Here you can see all four concepts illustrated. We have an entity type supplier with attribute types, supplier number, supplier name, supplier address, supplier city, and supplier status. Entities then correspond to specific suppliers such as supplier number 21, Deli Wines, together with all its other attribute values. A domain specifies the set of values that may be assigned to an attribute for each individual entity. A domain gender can be specified as having only two values, male and female. Likewise, a date domain allows to define dates as day, followed by month, followed by year. By convention, domains are not displayed in an ER diagram. A domain can also contain null values. A null value means that a value is not known, not applicable, or not relevant. It is thus not the same as the value 0. Think about a domain email address, which allows for null values in case the email address is not known. Various categories of attribute types exist, such as key attribute types, simple versus composite attribute types, single versus multivalued attribute types, and derived attribute types. Let's take a closer look. A key attribute type is an attribute type whose values are distinct for each individual entity. In other words, a key attribute type can be used to uniquely identify each entity. Examples are supplier number, which is unique for each supplier, product number, which is unique for each product, and social security number, which is unique for each employee. A key attribute type can also be a combination of attribute types. As an example, suppose a flight is identified by a flight number. However, the same flight number is used on each day to represent a particular flight. In this case, a combination of flight number and departure date is needed to uniquely identify flight entities. It is clear from this example that the definition of a key attribute type depends upon the business setting. A composite attribute type is an attribute type that can be decomposed into other meaningful attribute types. Think about an address attribute type, which can be further decomposed into attribute types for street, number, zip code, city, and country. A multivalued attribute type is an attribute type that can have multiple values. Diploma can be a multivalued attribute type of the student entity type in case the student can have multiple diplomas. Likewise, email address can be a multivalued attribute type in case a supplier can have multiple email addresses. A derived attribute type is an attribute type which can be derived from another. Age is a derived attribute type since it can be derived from birth date. Here you can see this illustrated. We have an entity type supplier. Note that entity types are represented as rectangles in the R model. Attribute types are represented using ellipses. Address is modeled as a composite attribute type consisting of attribute types for street, number, zip, city, and country. Supplier number is underlined since it is the key attribute type. The double line for the email attribute type indicates that it is multivalued. Finally, the dashed line for the age attribute type indicates that this is a derived attribute type, calculated based upon birth date. A relationship represents an association between two or more entities. Consider a particular supplier supplying a set of products. A relationship type then defines a set of relationships among instances of one, two, or more entity types. Here you can see the concept of a relationship type illustrated. The supplies relationship type models which supplier can supply what products. Relationship types are indicated using a rhombus symbol in the ER model. Basically, the rhombus can be thought of as two adjacent arrows pointing to each of the entity types. You can see this illustrated here for the relationship type supplies between the entity types, supplier, and product. The degree of a relationship type corresponds to the number of entity types participating in the relationship type. A unary or recursive relationship type has degree 1. A binary relationship type has 2 participating entity types, whereas a ternary relationship type has 3 participating entity types. The roles of a relationship type indicate the various directions that can be used to interpret it.